infinite sum. So let's consider the following geometric series. 1 plus a half plus a quarter plus an eighth plus a 16th plus 32nd, and it going forever. Well, our first term is 1, our common ratio is a half. Is it possible to find the sum of this series if it goes forever? And the answer is kind of. What we actually can find is a sum that is getting closer and closer to. Because if we think about it, we start off with 1. 1 is 1. Add a half, you get 1 1/2. Add another quarter, you've got 1 3/4. Add an eighth, you've got a little bit more. And as we keep adding these smaller terms, we keep getting closer and closer to a certain number. You can probably guess what the number is going to be, but a limiting sum is another word for an infinite sum, and that's what we're going to find with this sum, and we can use this formula to find it. So we can use the limiting sum is going to be a over 1 minus r. So it's a very simple formula. So our limiting sum is a, which is 1 over 1 minus our common ratio, which is a half. And if we do that, we just get 1 divided by a half, which is 2. So we're not saying that the sum of this series that goes forever is 2, but what we are saying is that it gets closer and closer to 2, but never quite reaching it. And we have a limiting sum only if we have a geometric series where r is between -1 and 1. And another way to write that is just the absolute value of r is less than 1. Let's have a look at one more. So we've got 3 minus 1 plus a third minus a ninth, and so forth. So this is a geometric series because our common ratio is -1/3, which is in between -1 and 1. And our first term is just 3, so we can find our limiting sum using a over 1 minus r. So we get 3 over 1 minus a third, and that's just going to give us 9 over 4. So this sum here, if it goes forever and ever and ever, it's getting closer to 9 over 4 without ever reaching it.